Welcome to another video in my channel. In this video, we shall be discussing two laws of logarithm. One is the logarithm of quotient and the other is change of base. Let us now look at what logarithm of quotient is about. Now, in this logarithm of quotient, if I have log to base a of x over y as a quotient or a ratio, it will give me log to base a of x minus log to base a of y. We can prove this law this way. Let us assume that log to base a of x is m and log to base a of y is n. Now, if I convert these two logarithms to indices, I have a raised to power m is equal to x and a raised to power n is equal to y. Now, since we are dealing with quotients, so I'm going to divide x by y. If I divide x by y, I have to divide a raised to power m by a raised to power n, which will give me a raised to power m minus n if we now apply subtraction law of indices. Now, let us remember that x over y is a raised to power m minus n. It is important that I put this bracket because these two numbers represent a term. Now, let us take log to base a of both sides. If we take log to base a of both sides, I have log to base a of x over y is equal to log to base a of a raised to power m minus n. Now, this raised to power m minus n, which is the power of this a, will come down to give me m minus n log to base a of a. Now, log to base a of x over y is the same thing as log to base a of a being multiplied by m minus n. Log to base a of a is 1. So I have m minus n is equal to log to base a of x over y. Let us remember that our m is log to base a of x. So I will write log to base a of x here. And my n is log to base a of y. So log to base a of x over y is equal to log to base a of x minus log to base a of y. Logarithm of a ratio or quotient is equal to the difference of the logarithms. There's another way that we can prove this law of logarithm, and we are going to use the product law of logarithm to prove it. So if I have log to base a of x over y, remember I'm going to get log to base a of x minus log to base a of y. Good. Now, let us apply product law here. This simply can be written as log to base a of x times y to power minus 1. And if I have this, that means that I am going to bring down these or separate these logarithms into their product. That is log to base a of x plus log to base a of y to power minus 1. Now, this power can come down. That is, we are now applying the power law of logarithm. So log to base a of x minus log to base a of y will give me log to base a of x over y. Now, let us look at change of base. Change of base simply has it that log to base a of x can be written as log to base n of x over log to base n of a. Let's notice that initially a is the base, but it becomes its logarithm to base n becomes the denominator, and this x still retains its position as a number, but it now has a different base. So the two bases must be of the same value. Now, to prove this, let us assume that log to base a of x is equal to y. Let's convert this to indices. That becomes a to power y equals to x. If we take log to base n of both sides, we have log to base n of a to power y is equal to log to base n of x. Now, if we apply power law, this power y will become the coefficient of log to base n of a. So if I go up, I now have y log to base n of a is equal to log to base n of x. Now I will divide both sides by log to base n of a. Log to base n of a. This will cancel this. Let me come here so we can see it clearly. This will cancel this, and when that happens, y equals to log to base n of x over log to base n of a. Let us remember what y is. Y is our log to base a of x. So log to base a of x is now log to base n of x over log to base n of a.